Hey, what's going on, folks? It's Mike here, and welcome back to my Programming Language First Impression series. A series in which we look at a programming language for the first time, or maybe one that I haven't looked at in a long time, for about an hour and just, well, explore the programming language, see how it is to get started, what the ecosystem's like, and overall just have a look at a language and look at some cool features and hopefully learn some things. Now, today we're going to be looking at a programming language called the Pony programming language. Now, I only had just heard about this a few times, and I heard about this from various other folks who are really into programming language who had said, oh, of course, you can do it this way if you're using the Pony programming language. So I said, well, that's one I haven't taken a look at. So I really don't know anything about this other than the description here from Googling here, and that some really smart programmers I respect are using or at least playing around with this programming language here. So let's just kind of scroll around here. I mean, I'm going to open up the homepage here. The GitHub might be useful. Looks like there are some Reddit posts here. RIP Pony. Well, let's see if folks are doing some stuff with it. Looks like there's some Hacker News articles, maybe a tutorial here. And this is, I see an Elixir post here, but it's an actor-based model programming language here. So we should probably also, let me open up another wiki for the actor model here. Let's go ahead and just bring that in, because that might be useful as well for us just to review. I mean, we looked at the Erlang programming language previously, and I suspect Pony is going to be maybe similar, or maybe it's derived from that as well here. So anyways, let's just take a look. I mean, here's the website. I've zoomed in a little bit just to help you read here. It's got a bunch of links here, some tutorials, help. So yeah, let's take a look around, and then we'll try to write some programs here. And we got a learn section here, which is perfect. So welcome. Okay, Pony is an open source, object-oriented actor model capability, secure, high-performance programming language. Okay, interesting. I mean, these are all things we like. Of course, security is at the forefront of things today. Actor model, again, from Erlang, which we looked at, which ran on the Beam virtual machine. So I wonder if this runs on a virtual machine, and then it's leaning into object-oriented again. Again, with the actor model, that kind of makes sense to be passing messages back and forth. So before we get into this, I mean, let's just go on actor model. I'm going to go on the wiki here. Again, this is just some other programming paradigm, but it might help. It'll help me if I just refresh this for, even a minute or two here. But okay, basically the way to think of actors, or at least how I sort of think about them, is how we are in the real world, like you and me, and then we can talk to each other, right? We can send messages and receive, right, by talking or communicating in some different way. And of course, we could do this concurrently. If I, as an actor, am talking to you, and there's other groups of people or whatever in the room talking. So it makes sense for concurrent applications to sort of have this message passing protocol. It's kind of like the observer design pattern. Again, if you've seen my C++ videos on that, for instance. But yeah, basically the idea is you're able to send messages back and forth, do something with those messages, so sort of send and receive. So you usually, again, in sort of an object-oriented manner, you would have like a queue where you're receiving and handling these messages, so almost like an event queue, and that's how you talk to each other effectively. And let's see, actors may modify their own state. Okay, so I guess, there's a bunch of different models here for how to work with the actor system, but at least that'll give us some maybe framework. That'll help me at least going into the Pony language here, but let's figure out what this language is here. I'm just going to kind of go through the links maybe in order here. So it's open source. That's cool. I do see the GitHub. We open up the GitHub here. I saw that post that said, oh, RIP. No, it looks like this is an active language. Even, just a few months ago, it was being worked on. Let's see what was being worked on here. It looks like it's still active to me. Like, folks are still fixing up stuff, and there's a lot of commits and so on. There's still new releases. Okay, so, I don't really have any worries about that. So we'll find out, though, as we dig into it. And I guess, let's see, Sean... I don't know who the author is, or what group of people are working on this language. There are a lot of contributors, though. 194. That's a pretty good number here. All right. Anyways, let's figure out what the language is. Yeah, let's open up the Pony Playground so we can actually write some stuff. Okay, cool. Are we getting assembly here? Okay, so it is compiled. They said it was a high-performance system. I like that. Now it looks like it is giving me like a language runtime, or maybe there's a VM or something, and LLVMIR here. So That's always good if it's built on top of LLVM. That means we get a bunch of different platforms. Again, we're not going to read this, but that's kind of cool if it's in the Clang ecosystem. Okay, yeah, I am interested in the history. Let's find out here. Okay, so Sean T. Allen. Okay, that was a name I saw on GitHub, so this must be one of the contributors. So there's writing early history of Pony. I still don't know who is writing this, but I kind of like this. This is funny. Okay, maybe this is just like a discussion style history. That's kind of neat. I haven't seen that. Okay, so fortunately, Sean gave me an outline on Slack based on stuff I've told him, so here it goes. Okay, cool. It is always kind of nice. I mean, this sounds like a very young language. So obviously that, it's kind of cool. You can remember some of the history, but of course, if you're going back to 2001, that still could be a long time for everyone. If you're trying to, just remember things. But okay. All right, so whoever the author is saying for years, since 2001, they would write a programming language. Okay. I when I first got into programming, I wanted to write programming languages. That was almost immediately one of the things I wanted to do, which was kind of funny, and I was still learning, but it was just fascinating. I wanted to figure out how that magic worked, and, I was able to figure out some lexing and parsing basic stuff, but not until years later I'd actually build some languages. Because it does take a little bit of computer science and know-how. But let's see. So anyways, the author here, okay, cool. They're working on flight simulators. I wonder, like Microsoft Flight Simulator maybe, or maybe other tools by other airlines. That's a really cool thing to be working on, and you have to know what you're doing. Let's see. Okay, so they end up building an asynchronous message queue system. Okay, for doing physics simulations. And of course, struggling with memory bugs. Yeah, I'm assuming in 2001, right? People were maybe warming up to Java then, but it was still, C, I'm sure. Because I wonder if this author was writing in like not C, but like a safe C or like some other like variant of the various C languages that there are, or maybe C++. So yeah, you gotta wrestle with your memory bugs. Of course, today we've got a lot more tools for that. But anyways, okay, the Flight Simulator went out in 2010, and the author was working for financial markets. Okay, so, sounds like they've done a lot of like high performance stuff, all this like distributed systems. Kind of cool stuff. I love that system stuff. Okay, but here's sort of the key moment. They met a research group, Slurp, fun name there, sound languages underpin reliable programming at Imperial College London. Okay, yeah, great institution. I was actually just walking by it a few days ago for the D conference, which is held in London. Okay, cool. Okay, so then they got to chatting with some researchers. Okay. So let's see. I'm just trying to get to the start of the history. I'm just going to point out a few facts. This looks like, I'll read through this, but eventually I want to get to it. But this is kind of cool. This would be a good... Folks are always asking about programming language or programming exercises, like building or implementing a paradigm as a library, so an actor model in C. That would be a great exercise. I'd have to think about that. Because again, I know a little bit about an actor, but I guess that'd be interesting to think about how to design it, right? Maybe if we use the Pony language a little bit, that can give you some ideas here. Okay, so yeah, this author's worked on some really cool stuff. So to use some fast queues based on Dmitry Voikov's work, sorry if I mispronounced that, on a work stealing scheduler. Okay, cool. Yeah, these work stealing, this is more in the... I haven't really worked in this space, but it's kind of a cool space with like operating systems or distributed systems where if you've got, let's say, a process that's empty or less busy, right, it can steal work off a queue, right? There's different algorithms for figuring out this kind of stuff here. So, okay, that's kind of cool. So they're working on some high performance compute. Okay, let's see. And why didn't it work for this high performance like work stealing actor model C library? Because C and C++. Okay, so too many memory errors are basically the problem here. This is actually kind of insightful to see how a language evolves, right? It's like watching interviews with programmers, but so I'm enjoying this full history. Okay, so what sort of motivated the language? Okay, so like pointer issues or deadlock conditions, right? So, these are the types of things where you just avoid in an actor model, right? Because you're basically just sending messages, they get queued up, and that's it essentially, as I understand it, right? So you're not really going to run into deadlocks in that. I mean, you might end up with deadlock in the sense that maybe you could get like starvation or something if you're waiting for a specific response. But maybe there's ways to like time out and so on in these systems. So, anyways, okay. So they're trying to squeeze a lot of work out of the systems. Let's see. Okay, and then eventually the author is starting to think about their type systems and the actor model. Okay, yeah, I had a feeling that it would be possible to express the actor memory isolation guarantees to prevent data races using some kind of type annotation. Okay, interesting. The C actor library did message passing without making copies. Interesting. Usually actor model languages make copies. Yeah, that's what I was assuming. You know, whenever Erlang sends a message. Okay, using ahead of time compiled native code. Again, thinking about Erlang, right? It has a VM, a virtual machine, and it can, you know, compile some of that code for performance. Okay, interesting. Using ahead of time compiled native code was important for performance for sure, but to be faster in C, C++, multi-threading approaches, we couldn't spend all that time copying messages. Yeah, for copying, we're going into memory. That's going to be slow. Okay. And then, yeah, if you're in memory, that's where you get data races. Got it. Okay. It can also lead to memory leaks, dangling pointers. Okay, all the fun stuff. With confusion about which actor should be responsible for freeing some data. Okay, experimented with reference counts, but ran into the usual problems with performance, too many reference count updates, and restricted object graph shapes. Okay, so language. Okay, sure, a language, but never write a programming language. That's like rule number one. Everybody will just tell you that it isn't needed and then argue about the syntax. Yeah, that is kind of true. But as we know in this series, we explore a lot of programming languages, and it's great when people... I encourage everyone to write their own. It's just a good exercise in general. And you never know. This is how we get new ideas, right? By learning from other languages and experimenting. So anyways... Okay, yeah, you have a bunch of this stuff already built into C here, but again, they're trying to get into something else here. Let's see here. Right, okay. Oh, interesting. So the author here went back to school. I wonder, did they go to Imperial College London to work at that work? Oh, interesting. Rather, I started a PhD program at Imperial with the lead researcher, Sophia, Dr. Drosopolo. Sorry if I mispronounced that as well. Oh, interesting. A part-time PhD. It's not as often, but I tell students they can do that. You just have to have the right arrangement, or usually if you've worked in industry for a while and have done, you know, some interesting stuff, that's kind of how you do it. But straight out of college, usually you don't go the part-time route, right, when you're younger. But when you're older, people kind of understand you have, you know, families, you've had some experience and so on, so it might be possible. It's just more rare, but that's kind of cool. All right. Anyways, so the author proved to themselves that they, oh, okay. So basically, yeah, they were getting into type systems and garbage collection. Okay, very cool. Okay, so they're having fun doing this. So Sophia taught a lot of skills. Okay, yeah, doing fun stuff, reading lots of garbage collection, type systems, and everything. Okay, and then they started working with Sebastian Blessing. Okay, so just trying to piece together the main folks that are part of this language here. Okay, and then they started a company. Oh, cool, Causality. Sebastian, Sophia, and the author. Okay, and then they added someone else. Okay, so they've got a bunch of folks here, including Sean here contributing. Okay, around 2014, the first compiled and ran programming language. Okay, that's all I really need here. Other than, of course, to answer who our mystery author is. The main author of the Pony Programming Language, Sylvan Klepsch, is the name here. Okay, cool. Okay, and here is, yeah, the history here. All right, just want to give them credit. Very nice here. So I'm going to read through this later just to get kind of... oh, here we are. At the very end here. Okay. Very cool. Oh, now they're working at Microsoft Research Cambridge. Very cool. Very cool. All right, anyways, so that's enough of the history. That was kind of cool, though, something we hadn't seen. So anyways, okay. So frequently asked questions. Okay, we read the history. Oh, we hear that a lot. If you've, yeah, why? Why it's called pony. We got to go back to this. Back in my fights and days when I would make my friends groan by telling them about what all the things I was going to do when I wrote a program language, one of the people I would tell was Nathan. One time when I gave him another laundry list, he said, yeah, and I want a pony. Okay. And also Harry likes horses. Okay, kind of interesting. You know, programming languages, like for those who don't know, Python, you know, sort of named after the movies, sometimes have funny names, so kind of funny to have a story there. Okay, so why would I use it? Why are we going to use this language here? Yeah, I mean, to this end, this is just part of the series, and I like that they're not trying to, you know, sell you too hard on it. That's kind of how I feel about languages. I think people should just use pretty much whatever they want, and if it talks to C, you're usually okay in a tool stack. Of course, that's sort of a wider discussion, but let's see here. Okay, so anyways, they're trying to move towards a 1.0 release here. And cool, I mean, so let's learn a little bit about the pony language. Does it really prevent data races? Data race and race condition. Okay. Pony prevents data races. It can't stop you from writing race conditions into your programs. Okay. Yeah, and this is John Riggers, who writes excellent stuff. I think he's at Utah still. Race condition versus data race. Cool, yeah. And he does a nice job with his blogs there. Okay, this is cool. Are there any examples of something complex built in Pony? Yeah, a few projects. Distributed stream processor, procedurally generated RPG. Oh, we gotta check that out because we like games on this channel. This is gonna be like Dwarf Fortress or something. Let's see here. Very cool. Yeah, it runs on some different platforms here. Mac. Okay, cool. Let's see what else on the projects here. Wallaroo. I feel like I've seen this, and I don't know how exactly to talk about this, but conflict-free replicated data types. Oh, cool. So yeah, all these sort of distributed databases, in-memory databases. Cool. Yeah, I'd be curious to see some of the performance, but it is cool to see some, you know, real projects anytime you have a programming language here. Well, a fast stream processing network. Okay, very cool. Does it have a formatter? Okay, no. So, you know, okay. What's your parsing? Okay, so they're going to work on some of the infrastructure and other tools and stuff. That's fine. Let's see some example. Oh, we got a ton of examples here. Okay. But I think I'm going to want to get started here, and let's see if it takes us to the tutorial here. I'll open up the standard library. Oh, cheat sheet. And is there a book here? A cookbook style of patterns. Okay, cool. Oh, they got mix-ins. Okay, so we got to check out some of this stuff later. Okay, so this I like. This I haven't seen. I'm trying to think on any of the programming languages that we've explored. Why not have a cheat sheet? Of course, people build these things, but it's kind of nice just to see this hosted on the actual website here. So if you're learning a language, you can paste it. But this gives us a good high-level overview of the program, right? You got your hello world here, which we'll explore in a moment. Our control statements. Looks like we got some pattern matching here, so folks are going to be happy with that. Loops. Oh, repeat. Okay, that's like me. I haven't used repeat since my basic days, but that's kind of cool. Repeat expression. I mean, sometimes you have this... like in D, you'd have like a dot repeat, but you know that's something you can use just for like you want to repeat a character or so. I mean, I guess this is the same thing as a loop here. I guess I don't know what the difference is with while. We'll have to look at that. All right, and this is a actor model here. So let's see here. We've got our private stuff, which looks like the underscore in front. We've seen that in a few different languages where the underscore matters. Here, let me zoom in just so you can see that to make a private variable. Stylistically, that's kind of nice. Again, maybe if I was designing a language just to make things more uniform, and this is probably why you can get away with not having a formatter, for instance. Because if your language is just very like in Python, for instance, the spaces matter. If you have enough of those different things here, your code should look kind of uniform. There's one way to do things. And I think a lot of new languages are leaning that way just to avoid the sort of complexity that can come with, really, really large languages. So anyways, okay, you got your, equivalent of what we'd think of as a constructor here, but initialization, your async behavior, and your synchronous behavior. So B, that's cool, and then fun. Okay, behavior. I've got classes, again, kind of following the same ideas here. Let's see, primitives only has functions, no members. Okay, that's kind of cool. Traits. Oh, interesting. So again, I didn't get a deep enough dive, and I haven't really touched Rust since, but right, people rant and rave about the Rust trait system, so I should take more of a look here. So I wonder if this is getting closer here. Interface. Okay, any class that implements. Okay, so I like interfaces. I like having these. We've got lambdas. Yeah, that looks pretty nice here. Literals, nice array, syntax. And then this is like the Erlang stuff. Message call, return receiver, method call. Comparisons is. Well, I like isn't too, just having the negation, because sometimes you don't know to put the exclamation like in front of is, just to make things kind of easy. All right, let's see what else we got here. Okay, yeah, these are looking like more like Rust-like things. So box and so on. Again, these were some things basically for the ownership, I guess, model here. Okay, so we got like read write. Okay, so we're gonna have to take a look at these here a little bit more here. I wonder if this is gonna be a really kind of nice language to learn if you're gonna go into Rust or something, right? Sometimes it's kind of nice to look at a related language and just see how they do those concepts, and then you kind of understand how so it more works in the other language. But again, that's the point of this whole series. Okay, so kind of neat to see here. Let's go ahead. I'm going to close the cheat sheet just so we don't get lost here. Here's the standard library. Let's just do a quick look. I'm going to follow the tutorial, but it looks like it's got a bunch of stuff here. What is a bureaucracy package? Let's see. It happens to almost every program. It starts small, tiny, if you will, like a village where every actor knows about every other actor, and shutdown is easy. One day you realize your program is no longer a cute seaside hamlet. It's a bustling metropolis, and you're doing way too much work to keep track of everything. What do you do? Call for a little bureaucracy. All right. The bureaucracy contains objects designed to ease your bookkeeping burdens. Need to shut down a number of actors together. Check out custodian. Need to keep track of a lot of stuff and be able to look it up by name. Check out registrar. Cool. All right. Seems like there's a little bit of a sense of humor here. I love this. I've never seen this, but it's totally right here. Okay, they've got nice examples. I mean, this is a nicely documented language. I like this documentation. Right, I can see the example programs here. This kind of reminds me of, like, in D you have scope, or other languages you have defer. But this seems like it's a little bit more maybe powerful here. You're keeping a set of actors to dispose of, or to clean up, right, to control. This is like the initialization and shutdown pattern, which you might have seen in like C++ books or in game development, right, where you want to dispose or destroy or shut down a lot of resources. That's what this looks like this is doing here, just collecting them. And then it looks like, oh, they have like a signal handler thing here that you just call on terminate. I don't know if that's the actual object here, but yeah, to basically call your custodian to clean up things. That's kind of interesting. Yeah. I just like the description of this. I wonder what else we're going to find in here. Of all the packages, that's what I see here. Okay, you got other things here. Let's just look quickly maybe at like strings, just to give folks a sense of, this stuff. Let's see what the string handling's like, or maybe there's more in just like the standard library here. Okay, maybe let's just get the tutorial and kind of walk through this. Let's see here. Okay, so we got through some of this getting started stuff here. We could try to build it too. Let's see if that might be something that we want to do here. Okay, I'm gonna put this off to the side here. That was John Greger's stuff here. Okay. Before we get started, last things here. Let's see the community resources just to see how the community is doing here. There's a Zulip chat here. Okay. So it looks like there is a forum here. Okay, and it's pretty active, right? There's people posting every day stuff here. Okay, cool. And they get different sections and so on. If we go to the tutorial. Okay, so cool. Let's see what else. How to contribute, community norms, other interesting things. You know, when you have a programming language, I like this kind of stuff as, you know, be kind to each other, you know, simple policies, but it's nice to have and to see this in the language, especially smaller communities to try to get things right. Let's see, getting help here. Okay, the Zulip community is the place to go, though. That's what it looks like here. I'm sure there are like Discord servers and stuff. I'm sure somebody's opened one up. If not, I'm sure they will over time. All right. Anyways, this is a tutorial. Okay, it's aimed at people who have some programming experience already. Yeah, that's usually the case. You know, whenever you've got a new language. So we're kind of the audience here if we've just programmed a little bit before. Okay, so we know about the language. It's type safe, really type safe, mathematical proof and everything. Okay, let's just click on this. Yeah, OOPSLA. Okay, yeah, this where these folks are publishing good top tier programming language conference, OOPSLA or Splash. Yeah, they've got like their operational semantics here. So this is going to be really interesting. I mean, we've looked at Haskell, which is a language that also sort of lives in the space of very like verified ML, Camel, OCaml, sort of in these you know, same families as well. It's memory safe. That comes with the type safety, exception safe, no runtime exceptions. Okay. I mean, again, you could kind of look at the author's experience, right, in flight control sims, where, again, that's the type of software where you're not necessarily going to throw an exception, right? You don't want to crash your software, right, or part of that software. So, yeah, all exceptional situations have defined semantics, and they're always handled. Data race free, okay. So, again, race conditions, again, you could still sort of have, but, and then it's deadlock free. Yeah, there's no locks. Okay. All right, cool. So the philosophy here is just to get stuff done. In the spirit of Richard Gabriel, the pony philosopher, is either the right thing nor worse is better. It's get stuff done. Okay. Incorrectness is simply not allowed. Okay. Performance is a big tenet of this language. Faster program can get stuff done, the better. The most important thing than anything except a correct. This is more important than anything except a correct result. Right, yeah. If your program is fast but not correct, it doesn't do anything. Interesting. Simplicity. Okay, yeah, we'll see here. Consistency. I mean, seems like language and completeness. Cool. A lot of nice guiding principles here. Get stuff done. Simple grammar. No loadable code. Everything's known by the compiler. Interesting, yeah. Now, that's kind of interesting. I guess in the actor models like Erlang, for instance, it's just-in-time compiling. My understanding is, I mean, you can basically just compile in new code, right, when you want to do something new. But if this is purely compiled, I guess that means that everything is, you know, checked at compile time and so on, right? So there's no like DL open or these types of things to load libraries. Interesting. So fully type safe. There is no trust me, I know what I'm doing. Coercion, yeah, okay, so no casting, basically, is what I'm seeing there. There's no upcast, downcast, maybe no implicit cast or explicit cast. You just do the right thing. Fully memory safe, no crashes. Very cool. I mean, these are things that, you know, a lot of the world's... I mean, there are programming languages like here. There are contract-based programming languages. We looked at Ada a little bit. You know, for writing secure software, right? Because there are domains where you don't want the software to crash, right? Anything usually involving vehicles is sort of in that family of things here. Sensible error messages. Okay, this is all good stuff here. So let's sort of see. Let's go to getting started. We might need to make this A little bit smaller. Okay, so what do I need here? We need the compiler. Okay, so we need to build our program. Pony C. Should we build it from source? Let's see, is there a makefile? There is a makefile here. We could try it out, why not? Let's clone just to see. Let's see what happens here. Is there a CMake? There's a CMake list here. Okay. I'm just going to try this without reading the directions, as one does here. Let's just make a build directory. And then run CMake. Let's see here. Okay, I might not have the right like LLVM version set up here. Okay, so I might cheat here. Let's see here. Where do I have LLVM? I do have a LLVM build here. Let's see. They're containing one of the files here. Let's see. Do I want it in my build of LLVM? I guess I've still got it here. Let's see if that does the trick here. And do I have my CMake prefix path? Is it in this one? Well, let's just try both of them here. Okay, add LLVM dir equals this. Let's see if that works here. Oh yeah, I gotta remove these guys here. Yeah, CMake cache, CMake files. Oh, maybe that wasn't the right one. Let's see here. Echo LLVM dir. Oops. Okay, if it's not that build directory, maybe it is the actual like LLVM project or something. Oops, then I gotta remove these guys, blow these guys away. Let's try this here. Could not find, okay, I don't have this. Okay, I'm just gonna use the web browser here. I don't feel like, maybe I'll come back and build this later. If folks are interested, I can do that. Does look like a problem. I just gotta install LLVM in my package manager, but I like to just, always build LLVM from source, so I don't want to do that necessarily here. Let's just get into, I mean, we have the thing set up. Where is it? Oh, here it is. Let's just go for this, just because we're about halfway through and I want to write at least a little bit of source code here. Okay. Anyways, back to the getting started. Our overview. Let's see here. Let's write our first program. Actor main. Well, it's already given to us here. Okay, so a few different things here. Okay, we got to make a directory here. Does the name of the directory matter? Yes. Okay, so it is going to use some sort of like package, maybe system here. Executable binary will have the same name as the directory a program lives in. Okay, so it does matter. Okay, does the name of the file matter? Not to the compiler. Okay, just the directories. Okay. But it might matter to you, and the file should probably end in .pony. Okay, no problem there. And then you just run it, generate it, and optimize it. I guess it's doing an optimized build by default, and that's it. That's kind of cool. It just finds the files here, and that's it. Yeah, maybe we should try to get it built and linked as well, but oh well. Anyways, let's just run this hello world here. And let's see here. Can I make this larger? Hello world. We see it at the bottom here. Program ended. Compatible with LLVM 15. All right. Defaults. PIC. Position independent code. Is that what that stands for? Let's see. I don't know. All right. So hello world. How does it work here? Okay. Line by line. Actor main. This is the type declaration. Okay. Actor means we're going to find an actor, which is a bit like a class. Okay, Pony has classes too. The difference is with actors and classes, an actor can have asynchronous methods called behaviors. Okay, yeah, so this is going to be our default where we get the most power in our program. A Pony program has to have the main actor, okay, which we have. That's kind of like the main function. Okay, so no problem there. And then this is our like initialization code. This is a constructor. Okay, so they do call it constructor. The keyword new means a function that creates a new instance of the type. In this case, it creates main. Okay, unlike other languages, constructors in Pony have names. That means that there can be more than one way to construct an instance of a type. In this case, the name of the constructor is create. Okay, new create. The parameters of a function come in next. Okay, here we are, env colon env. In this case, your constructor has a single parameter called env that is of type here. Okay, so the type is after the name. A lot of languages doing that. I actually kind of like that because if it makes it easy if I'm parsing to have like x, y, z or something there. If I want to have multiple variables, then the type following. So that's kind of nice here. Okay, C, C++, you'd have the opposite, but we do it the other way around. Yeah, like a bunch of other languages. Yeah, and I actually think that's the right way to do things anyways. Or it's easier, so you can support that sort of functionality of having, I think at least reads better. Anyways, turns out main actor has to have a constructor called create. Okay, yeah, because this is our main, so fair enough. Okay, what's with the body? It's the code that comes after this guy, the equals and greater sign. This is our program. What's it doing? Dot is either a field access or a method call. Okay, much like other languages. Again, that's one thing I like in like the D language. You just put dot. You don't have to worry about arrows and other stuff. Although this, we do use arrows, I believe, in like actor-based languages. Okay, so we looked at the field out, and in this object, env, as it happens, this represents standard out. Okay, which writes out to our console. Okay, so this is basically our, print line function here. Okay, string literals can be in double quotes, okay, or they can be triple quoted, like in Python, in which case they're considered raw data. Okay, cool. What's an environment? It's the environment your program was invoked with. This means it has a command line argument, environment variables, standard in, out, and air. Pony has no global variables, so these things are explicitly passed to your program. Okay, so yeah, if I want to have globals, again, I need to like pass them in some sort of environment from one to the other. Again, that's sort of the actor model, which is a little bit different, right? I can't just come up here and just say like g global var of, int or whatever, we're going to find out it is. Okay, can't do that. Got to pass everything around. And that's one way that you get, a lot of memory safety and avoid data races. Okay, so we know how it works. Again, this is nice documentation here. Types. Pony's type system is what makes it special. Okay, let's see if I zoom out of this enough. Will I get the... I will. Okay, it's going to make it small here. Okay, let's look at a glance here. This is kind of nice. I mean, the documentation reads really well. You can actually read a lot of, learn a lot of programming language stuff, right? If I was teaching a programming language course, I would probably have students read this documentation. It's statically typed. So again, it's explaining what that is. What's the difference? We sort of know, right? Static, a type always is what it says it is, and dynamic it can change. Okay. Now in Pony, let's see. I guess the compiler is just going to crash here. Okay, so it's talking about. Let's look at some of the guarantees that Pony's type system has here. If your program compiles, it won't crash. That's cool. Again, that's we can learn a lot from this actor model, and static systems, right? And provably, maybe we should read that 18-page paper, and then be serious about that because, you can learn a lot about program safety, I think, from diving into a few of those, OOPSLA papers that are well written. Anyways, okay, never an unhandled exception. There's no such thing as null, so you don't get null pointer to references. Okay, so these are all like the safety features here. All message passing is causal, not casual. Okay, we have to read that carefully here. Causal order of messages. Dave Season, okay. This looks like something we should take a look at here. So again, learning a lot of stuff about systems and relearning, refreshing, just by reading the documentation here. So really nice. Okay. Okay, so yeah. So for security, this does mean a lot. If I use Pony's foreign function interface to call code written in another language, does Pony make the same guarantees for the code I call? This is a good question here. Okay, so yeah, so if I can call into C or something, right, you don't have guarantees. I mean, that's true of any language, right? You're in a different ecosystem. You're executing code in a different way with different guarantees from different compilers. So that is nice to know that there is at least a way to talk to the rest of the world and other ecosystems, which is important for a programming language to grow. But yeah, that's an important point to make. That yeah, you're not necessarily type safe anymore. Okay. Let's see here. Classes. What goes in a class? Some fields. Let's write a little bit here. Just as we go here. Let's build a class here. Let's see. Can I just build it out here? Class Wombat. Let name string. Okay, uppercase for the types here. Var. This is going to be private, right, with the underscore. U64. Okay, so they got their fixed with types here. Let's see here. Field left undefined in constructor. Let name string. Oh, interesting. Okay. Field left undefined. I guess I have to create these. Okay, that's the next thing that they're telling me here. Okay. What does leading underscore mean? Yep, that's private. We talked about that. Constructors. Okay, let's create our constructor for this wombat here. New, create, name. Oh, it's got a little backtick behind it. What is that here? Is that intentional? I see it a couple of times here. I guess that's just a way, usually variables can have underscores and letters and numbers, as long as the number's not the first thing, but I guess the little backtick's just their stylistic way of assigning name to something. Okay. That's also something we haven't seen, or I haven't seen in languages so far. We've looked at a lot of languages in this series, so it's always fun when we get a new surprise. These different styles here. The other thing that's kind of nice is they've kind of figured out that we don't need semicolons after everything here, so that's kind of cool here. That we figured out parsing after many years of toiling. Now, of course, this editor is adding double quotes there, so I gotta fight that a little bit here, but that's okay. That's not a big problem. Okay, the return name equals name. Okay, so we've got a couple I don't know, constructors here. Hunger level equals hunger. Okay, let's try to run this now and see if it'll still run here. Hello world still. Okay, and I've got my class here for my wombat. Okay, so I got two constructors. Now can I initialize some wombats in my main? And I'm testing this to see if I can do it out of order too. Meaning that I have the class definition later. So default wombat equals wombat. Fantastibat. Okay, and let hungry wombat equal wombat. Oh, dot hungry. Okay, that's this one. And since I'm using new, that's the constructor that we've got here. Okay. Nomsbat hungry. Okay, 12. Let's make this a little bit larger here. And let's give that a run. Didn't make any errors. Testing out the errors here. Line. Syntax error. Unexpected token colon after type interface. Let's see. What have I done here? Colon. Well, that looks like what I'm supposed to do, right? Or is there a space that's not supposed to be there? Let's see if it's that tricky. String. Okay, that's the name. Create. New. Create. Name. String. Let's see. Now I'm not getting this syntax highlighting here, so maybe I did have to. Let's move this up here. There we go. Okay, so maybe that answers my question about doing things out of order here. Okay. Whoops, did I... literal doesn't terminate here. Oh, did I add an extra... Ah, there we go. Okay, I must have just added something. Okay. Okay, so I do need to put things in order. That's fine. That's not a big deal. Or at least before my actor main here. Which makes sense here. What's with the single quote thing? Ah, here it is. It is highlighted. You can use single quotes and parameters with local variable names. In mathematics, it's called prime. I actually do like that. You know, we use underscore a lot. Sorry, I'll make this a little bit bigger. So I do think that's a good idea to allow us one more character in our programming languages. Alrighty, so let's see. Every constructor has to set every field in an object. If it doesn't, the compiler will give you an error. Okay, so yeah, that's kind of nice, right? We want to know that things are initialized, right? We don't like, undefined values. Again, coming from the experience, I like variables being initialized, even if they just pick a default value. That's better than just having garbage in there. Okay, so we have 0 argument constructors, some different class types here. Functions. Let's add to our wombat a hunger function here. Function hunger u64 is going to be the return type, and we'll get back the hunger level. So let's see. Let's get our environment.out.print from our hungry wombat hunger. Let's see if this just works here. Argument not assignable to parameter. Okay, let's figure out how we can print stuff out here. Let's see, that would be one of the next things I would put in a tutorial here. I wonder if I have to assign it to a value and then write it out here. Let's see. Let's try like let val equal this. Can I just print u64s? Expected variable name after let. Oh, val might be a keyword. Value. Let's see here. Argument not assignable to parameter. Okay, so we got to figure this out a little bit here. I want to print the wombat's hunger, and then we'll consider this a success. Okay, we do have the none value here. Okay, returns, value. There's no return keyword used. Okay, so again, with functions, I've seen this in a few other languages as well. The last value is the return value, right? The last thing that's evaluated. That's fine. I mean, it sort of makes sense. You just stuff in your register, the result of whatever the last expression was. Is there a return key? Yes, but it allows you to return early. Okay, so you can still do that. Yep, that's fine. Okay, and the ref keyword. Okay, let's scroll up here a little bit. Okay, here. After this function. Okay, so this is what's going to let us to assign things or change. Let's see, a reference capability. In the meantime, it means the receiver, i.e. the object at which the set hunger function is being called, has to be a ref type. A ref type is a reference type, meaning it's mutable. Okay, so that's how we get our mutability. Okay, so everything's immutable by default. That answers one question here about the programming language. And again, that's where you get a lot of safety. Again, these days, folks, at least if you're building a safe language or that's what your goals are, that's probably the right default, right? Make everything immutable and then explicitly put like ref or mutable or some keyword to indicate that it can change here. Okay. Need to be able to read this and write this. Okay, so that's where we saw in the cheat sheet all the different like read and write rules here. Okay. Return is the old value. Okay, this is the default value. Oh, interesting here. Okay, so here. Okay, so I've got to assign this value to 2 to return it here. Okay, for this return value. Otherwise, it's saying, basically if I don't, it won't, it's not going to mutate this or return anything. Okay, interesting. Putting the value of the old value is A, Finalizers. Okay, we have final and so on. Okay, so there is inheritance and other stuff here. Okay. Let's just keep exploring the language, and we'll see if we can print something out here. Let me just see this error message, see if we can figure it out. Argument not assignable to parameter. Value is u64 val. What's this requiring? It's requiring string val. How do I convert? Okay, it's telling me it's not a subtype. Okay, so this is like day one, pony programming, how to figure this out. Pretty good error system, though. It is giving us some information. I am going to cheat a little bit in Google in this other window here. There's a format package. Okay, for formatting strings. as well as controlling how numbers are printed out here. Let's see, is that how I display something like this? Use format. Okay, let's see. Can I bring in a package in this online editor? Use format. And can I just do this for display? Oh no, what is this here? Did they define a function? Oh no, I think this is what's given here. Value as value? Let's see. What does this do here? Let's match our parentheses. Can't find declaration of display. Okay, I gotta define this here. Example program. V or with, okay. Oh, these are I32s though, uh-oh. Oh, maybe this is a little bit more confusing. Do I have to copy this function here? I don't really care so much about the formatting of strings here. Okay, hold on. Let's see. Maybe we'll get to it in the tutorial. That'll be our end goal to figure that out here. Let's keep looking at some of the interesting stuff here. Okay, primitives. Similar to classes, a primitive has no fields. Okay, just member functions. Okay, so that means they're never mutable. Interesting. So, I mean, there are like the different programming languages, depending on where you look. Like Pascal has records, which are just plain old data types. And then you have like classes or whatever, where you can have everything. And this is going sort of the opposite direction. You can only have member functions or methods. That's kind of interesting. What can you use a primitive for? Okay, 3 main uses, yeah. As a marker value. Okay, that's something that has no value. As an enumeration type. Interesting. And a collection of functions. Okay, yeah, so you could group them, yeah, like your math functions. Okay, that makes sense. I see, so that's sort of one. I mean, that's the obvious way to organize stuff here, this primitive here. Okay, an enumeration type. Interesting. Okay, primitive, open door, and closed door. I see. Okay, makes sort of sense here. I see, so even the built-in types are primitives. Ah, okay. Yeah, that's kind of interesting. I never thought about it in that sort of way. That's kind of a nice way, again, to organize things, put them together. Again, a lot of great programming language research has gone into this language. It's pretty neat here. Behaviors, like a function, except that they're synchronous, and behaviors are... Oh, okay, yeah. Let me get this right. Behaviors are asynchronous. Okay, so this is where you do your async stuff. I mean, this is where languages like, Erlang and stuff, where you have a giant telecom, where you have to make a lot of, different phone calls amongst concurrent users, right? You want asynchronous behavior. So again, this sort of makes sense here. Okay, so I just need to put B in front of this, and then I can asynchronously run this function here. Okay, and we're a little bit familiar, if you've been watching this whole series, with message passing, or when we talked about the actor model here. Let's see here. Okay, so the system is equivalent in Erlang. When you call behavior on an actor, you're sending it a message. Yeah. Okay, cool. And they're going to go into this. So, so they're executing exactly one behavior at a time. But it's nice to think of actors not as a unit of parallelism, but as a unit of sequentiality. Interesting. Yeah, this is pretty cool here. I will probably come back to this and read all of this, because it's just such a great... Looking at this language is, I could probably read an Erlang book, but this is explaining the actor model, or it's set up, in a very nice, clean way here. Probably languages, that lean into this actor model are... underrated, I would say. I really like the idea of message passing. It's the thing that's forgotten in object-oriented programming, really. Maybe it's because people associate it more with Erlang versus like Smalltalk or something with the message passing, which maybe we could look at Smalltalk at some point on this series if folks are interested. Okay, so I'm looking at the subtyping here. Okay, so we have interfaces and so on, and traits. Okay. I mean, we're getting towards the end here, but I just want to kind of give a preview, keep giving a preview of the language. Let's make it at least through the tutorial here. We've got structs. Structs are classes for foreign function interface. Got it. Okay, for talking to C code, basically. That's the idea. Okay, that makes it kind of clear when you find it in the help what to do. Type aliases. Okay, so we got type aliases and this kind of stuff here. Type expressions. Similar thing here. Tuples. Okay, cool. Oh, cool. Tuples, union. Okay, and they're making the union look more like a tagged unit or like a variant, which is kind of cool. And they've got intersections, which is kind of cool. Yeah, this is kind of neat stuff that you don't see as much in the C-based languages. Okay, so there's a lot of interesting stuff here, and the tutorial is pretty well written, especially, you know, if you're into programming languages and stuff. This it's nice that one of the things that I'm appreciating that the concept is being explained, like what is a static or dynamic type before just saying this is a statically typed language. So a lot to learn about the documentation of these, you know, from these languages as well. Okay, let's try to achieve our task of just printing out a U64 here. And I'm probably just going to, let's see, where would I learn this? Somewhere I saw a list of examples. Yeah, in here. I don't know, like a circle example. Let's see here. Okay, it's printing out the radius and stuff. Let's just go ahead and look here. Let's look at some code. Okay, what is going on here? Oh, we do have a dot string. Is it as simple as that, just doing dot string? That would be brilliant if that's the case here. Value dot string. There we go. It is that simple. Okay. Phew. Okay. Let's see. Okay, foreign function interface with structs here. This is all very nicely documented here. Path to the shared libraries. Let's see. Okay, so they're doing an example, compiling some, you know, C code or something. How do they expose it here? Let's just look at this last example here because I'm kind of curious. Okay, here's a struct. Okay, they called it outer and inner. Let's just try to focus on one of these. Maybe inner, which just has like this type here. And I guess, okay. I guess they're just specifying some of the semantics here for the types here. Okay, interesting. Use. Okay, this is using the structure. I mean, this is the matching whatever the C interface is here, so that we can call it. And then you have, you know, whatever the C implementation is here. Yeah, nice examples here. Okay, and this is showing how to compile it. Let me see here. Where's the pony code getting linked in here? Here's building the different libraries for Mac and Linux. Where's the pony C compiler? I guess it's just doing use and then it just finds it. Okay, that's simple enough here. That's kind of cool. Oh, is it as simple as just doing like FFI struct or something? And then it just links it in. I guess it just finds it here. Oh yeah, okay, with minimal pony insertion, same directory. Yeah, I guess that's it. That's kind of cool. Okay, so you know all the C code or whatever that you've written, you can check out. Mandelbrot is here. Cool. Okay, so some nice examples. N-body simulations. I mean, that might be kind of cool just to see for like performance or to try to get some benchmark of this language. I mean, overall, what I can say here, I mean, here's just another look at the little code we wrote. Classes, actor. It's kind of cool. I mean, the actor model makes more sense to me after looking at a few of these languages and spending a little bit more time with it. And the ideas of message passing again. And I mean, just the general stuff that's really cool here with the safety of the language, I think is neat. So, you know, I give it a thumbs up. I can see why, again, some smart people that I have, you know, some chats with told me to check this out, and I'm glad I did. I think it's really well written. I think I'm going to look through the documentation and keep it bookmarked just for various programming language concepts or when introducing to other folks. So there you have it, folks. Let me know if you enjoyed that. Let me know if you want to look at more actor-based languages in the future. I quite enjoyed this. I mean, let me know if you're using the Pony language, if there are other cool projects we should know about or highlight that folks are doing. It seems like a really cool project, and it's totally open source, which is cool. It's got a nice history, and it looks like it's been well developed. So again, otherwise don't know too much about it beyond that, but we're able to find some core resources and again, explore some really cool concepts that we haven't seen, and even just stylistic things like being able to put a little tick mark for a prime for the variables was really cool. So anyways, folks, with that said, thanks for your time and attention. As always, I'll look forward to hearing your thoughts, and I'll see you in the next one.